Hello, and thank you for joining me. This is the average power in a purely capacitive AC circuit. So we're looking for the average power in this purely capacitive circuit, and the way I'm going to solve it is with phasors. So I've gone ahead and drawn out what that circuit would look like, an AC voltage source with just a capacitor connected. Here's our phasor diagram, and we're about to fill it in. So without further ado, let's just get this started. Now, what does the impedance phasor look like? Well, that's going to be negative J, right, because it's a capacitor, um, divided by omega times the capacitance. And so to convert that rectangular form to a phasor, since we have minus J, that's going to be, you can think of it as just, um, you know, 0 in the real direction and minus J in the imaginary direction. So as a phasor, that's going to be a magnitude of 1 divided by omega times c, the capacitance, with an angle of minus 90 degrees. So we'll start here and we'll go minus 90 degrees and give it a magnitude of 1 over omega c. Now, what's the voltage? The voltage, let's just call it V max as the magnitude, and the angle we'll assign as 0. Now, how do we use these, right? Well, we're looking for power. So we're going to do the apparent power, S, equals V squared over the impedance. Well, that's going to be V squared, right? It's just V max squared. And then if you multiply these two phasors, you add their angle together. Well, the angle is 0. So when you add this plus another, the angle stays 0, but the V max is squared. Now, when I divide by my impedance phasor, I'm going to take the omega c up to the top, and then I take the angle that I had 0 degrees as my angle, and since I'm dividing by this phasor, we actually do 0 minus negative 90 degrees for a total of positive 90 degrees. So this is the magnitude that the phasor, this is the magnitude that the apparent power phasor would have. And then this is the angle, positive 90 degrees. So we can see that there's no component of this phasor that goes in the real negative or positive direction. And what is power but the real part of apparent power? So what's the real power in this angle, or in this phasor? Well, there's no part that's real, right? We have our real axes on the left and right. There's no part of this phasor that's real. So P average is going to be 0, and the answer is A.